We've all been there. Tossing, turning, and finally kicking that one leg out from under the heavy blanket just to find a little relief. But why does finding that exact room temperature act as a strict biological prerequisite for sleep? It comes down to an absolute command from your circadian rhythm. Roughly 2 hours before bed, your core body temperature must drop by about 1 degree Celsius. To pull off that temperature drop, your body relies on vasodilation. This physiological process expands blood vessels in your hands and feet, dumping excess core heat. This internal sequence relies entirely on your room acting as a receptive heat sink. Your body requires an environmental Goldilocks zone of 65 to 70 degrees Fahrenheit. Pushing the ambient temperature even slightly outside that narrow window triggers primal survival protocols. Your bedroom is an active thermal vacuum. It must perfectly accommodate your biological heat dumping sequence, or your sleep architecture instantly collapses. Say your room is warm, above 75 degrees. This closes the thermal gradient between your skin and the air. Without a cooler environment to accept that energy, your body is prevented from dumping it, trapping heat inside your torso. To avoid dangerous heat stress, your brain actively refuses to initiate slow-wave deep sleep. Clinical data shows this thermal blockage delays sleep onset by 15 to 30 minutes. You end up with a fractured sleep architecture, held hostage in a shallow, unrefreshing cycle of light sleep. A hot room physically bars the neurological gate to deep sleep by suffocating your body's natural cooling mechanism. Drop the room temperature into a chilly sub-60 degree zone, and a different problem emerges. Extreme cold triggers TRP sensory channels. These are specialized proteins in your nerve endings that detect temperature drops and send immediate alarms to your hypothalamus. Your body launches an aggressive survival response, initiating involuntary muscle tension and shivering thermogenesis, a physiological defense where your muscles rapidly contract to generate emergency heat. Because of this defense mechanism, your brain is continuously bombarded by arousal signals. You experience highly fragmented rest, riddled with tiny macro-awakenings. This neurological chaos severely impacts REM sleep. REM, or rapid eye movement, is the cognitively critical stage where we process memories and dream. During REM, your body practically paralyzes itself. More importantly, it entirely ceases to regulate its own temperature. If the room is too hot or too cold during this phase, your brain aborts the dream state to protect your physical safety, slashing your total REM duration by 20 to 30%. Thermal extremes trigger primal alarm systems that actively amputate the most critical stages of your physical and cognitive recovery. This reveals a major flaw in how we design our sleeping environments. Setting a thermostat to a single static temperature for 8 straight hours is biologically incorrect. Because you abandon thermoregulation during REM, your environmental thermal needs actually fluctuate dynamically throughout the night. Recent polysomnographic research, which involves comprehensive sleep studies tracking brainwaves, oxygen, and movement, points to a biological corrective, real-time temperature adjustment. This chart details how real-time temperature adjustment, or RTA, dynamically changes a mattress's temperature based on your current sleep stage. The orange mattress setting line drops by several degrees, precisely when the sleeper enters the highlighted REM blocks, and warms back up for non-REM sleep. This chart visualizes the clinical results of that targeted thermal adjustment on total sleep time and sleep efficiency. We can see the stark growth of the green RTA bars compared to the blue control bars, representing a statistically significant jump in overall sleep quality. This next chart displays REM latency, which measures the time it takes to enter your first dream cycle. The steep drop in the green RTA bar demonstrates a much faster entry into REM, alongside a measured reduction in periods of wakefulness throughout the night. Sleep is an active, ongoing physiological negotiation with your environment. Protecting your microclimate across every distinct sleep stage is the only way to signal to your brain that it is finally safe to power down.